Good evening, friends. Now, this is a series of lecture related to UV visible spectroscopy, the chapter number 5, which is credit-based system of TYBC in this current year. Now, here we will focus on the detector and which type of detectors are employed in the detection system to measure the absorbance and percentage transmittance. There are a number of detectors like photomultiplier tube, photovoltaic cell and phototube, as we have already learned about it. Now fourth and last one, that is silicon photodiode. Silicon photodiode consists of a PN junction and joined to DC power supply to form a reverse bias. So silicon photodiode is based on the reverse bias concept. In reverse bias, PN junction is joined to negative terminal of DC power supply and N region is joined to positive terminal of DC power supply. So P region is there, that is positive holes, and negative region, that is a negative terminal, that is a negative electrons. That is the minus sign is associated with the electron, and holes, that is a positive sign, is associated with the P region. In reverse bias, P region is joined to negative terminal of DC power supply and N region is joined to positive terminal of the DC power supply. Due to this reason, positive holes and electrons in respective region travel away from each other towards the end of the diode. This gives rise to the deformation of a depletion region at PN junction of diode. When UV or visible light is incident and strike the depletion layer, additional holes and electrons are created, which can be layered. Additional holes and electrons are created which can be easily detected. The increase in conductivity of diode is directly proportional to radiant power of incident light. The silicon photodiode is more sensitive than the photodiode but less sensitive than photomultiplier tube. So hence the silicon photodiode is useful because it has a high sensitivity. If we see the typical diagram of silicon photodiode, then we will see that these are the positive holes and these are the negative electrons, and in the middle region this is the PN junction. Now where we apply the proper voltage to the silicon photodiode, at that time positive holes are attracted towards this negative terminal of DC power supply, while these negative electrons in the N type or N region, which is connected towards the positive terminal of the DC power supply. When a proper voltage is applied, at that time this PN junction or depletion layer is get distorted, and the widens, or you can say the widely wide, then there is a proper wideness observed in the depletion layer. The proper wideness observed in the depletion layer is directly proportional to transmitted amount of radiation on that depletion layer. So that is the main principle, working principle and construction of the silicon photodiode. So with this content I conclude this lecture. Thank you very much for your patience listening.